Hi. Today I'm going to show you our project for embedded systems, ECE 5780 or 6780 since we're grad students. And we did a irrigation pressure monitoring system. The motivation is with irrigation systems, it's hard to monitor pressure for failures. If a crack in the pipe happens or something were to blow out, pressure would indicate that something had happened, but getting it to where a person could actually see that data would need to be done. So we came up with a wireless system to do this for us. So first I'll talk about the test setup that we've got right here. The pressure sensors themselves are right here and here. Their range is 250 psi for this one and 100 psi for this one. And then they're connected through a sealed PVC pipe setup. As a note of caution, if you were to recreate this, make sure that you do put water in this pipe, not air, because if this were to explode, it would send shrapnels everywhere if it was air. But this has water in it. We've also got a place where we can insert pressure into the system, a place where we can fill it up with water, and about right here so we can separate the two. Now a word about the pressure sensors themselves. They take in 5 volts and then give a output range of 0 to 100 millivolts. Now that's a pretty low range. We wanted something with a larger range because our ADC can take up to 2.65 volts. So, I'm going to bring it in. I set up an amplifier circuit. I set it up so there's a gain of about 21. So it would scale that up to a range of 2.1 volts, which is much closer to what we'd need to be to utilize more of the ADC's range. So it comes through here, comes through the op amp, and then comes over to the board here where it goes directly into the ADC for the microcontroller. The microcontroller takes that value and then calculates the PSI it's detecting via a lookup table that I've stored on the NV memory in the Smart Fusion board. And then from there, it goes through the wireless, and I will hand it off to Meysam to explain that.
Okay. Hi, everyone. I'm responsible for sending information provided by Matt and send this information to a server. At first, we have here a board, Smart Fusion, that have a microprocessor Cortex M3, and also we use this chip to send the information which is called Wi-Fi. Wi-Fi has a SPI port and also UART bus. We use UART bus in this project, so the information that is provided by sensors are come here, and the CPU can send this information to this board by using the UART port, and we here we can configure it, for example, the information of IP address of host, the port that is listening, and the port is sending information, and also it has a DHCP. We can turn it off right now. Send this information to our server by the UART, by the UDP communication.
Hey everyone, my name is Ray. So I'm going to show what happens once we send the information from the Wi-Fi to the server. This is a Arduino board. So a really nice board with the I2C SPI and all the interfaces. This is a Wi-Fi interface. So this is our master. The idea is this would be the master station, and all the different nodes in the field would send all the pressure readings through their wireless systems to this master station. This master station stores and it collects and stores the pressure sensor data for every sensor, and this is where we are hosting the web server. And once all the data is stored, and we can access it from using a web page or just any other means of getting access to the internet. So what I will the last part of this thing is accessing all the data from the master station on the iPad. So I'll just but before we get to that, I'll just give a complete demo of the system. So again, as you recall, so we have a pressure system. We have 2 pressure sensors, and start it up. I'm going to show the starting pressure of the sensors, and then show what happens as we increase the temperature, as we increase the pressure.
Right now, Ray just connected to the wireless ad hoc network that we set up for this sensor network.
So as the top box is actually showing the pressure in the PSI of the sensor number 1, and I will start to increase the pressure in the pipe, and it should change accordingly. So right now it's reporting at 64 psi. As I increase it, it has jumped to 74 psi. So this is the main idea. So again, the pressure is being measured through the ADC to the Smart Fusion board and being sent over Wi-Fi to the Arduino board, which stores all the data. And again, we can also access all the different pressure readings by just going to the web page of each of them. So this shows the pressure of the sensor number 2, and again, and this would be. And these are the pressure readings of sensor number 1. That's kind of a nutshell of the whole project.
Thank you.